What you need to know for the Chapter 12 test? Everything. Good. Any questions?
All right, no, that's a wrap.
All right, so let's start with y equals ax squared plus bx plus c. We're just going to call this standard form. Okay, we've seen these before with factoring. We'll get to that a little bit later for solving, but we're more thinking about the graph that this forms. What kind of graph does it form when you have an x squared?
It's a parabola.
Yeah, it is a parabola. So the basic just x squared would look like that. If you needed to, you could plug values in and plot the points. That's going to kind of be a last option for us. There's other important things we can just pull from the equation that work for us. So let's start and just look at an example. Let's go y equals x squared plus 4x minus 5. So the first thing we could look for is the axis of symmetry. So in this form, when it's the x squared plus something x plus a constant, it's x equals negative b over 2a gives you the axis of symmetry. So what's the b value?
4.
4. So negative 4 over 2 times what?
1.
Okay. Negative 4 over 2.
Negative 2.
Negative 2. So that tells us that the graph here has a line through negative 2. It's x equals negative 2 that cuts it in half. So if I had this eventually graphed, I could fold it on that line at negative 2 and it would match up. It's symmetrical right there. Okay, that also means that's where the vertex is. It's on that line. So we use the axis of symmetry to get the line. But we also use that to get to the vertex. So now that we have it, to find the vertex, you plug the negative 2 into the equation. So it's y equals negative 2 squared plus 4 times negative 2 minus 5. 4 minus 8 minus 5. So look like to you guys. Negative 9. Okay. So that tells us on the line of negative 2, the vertical line, we have to go down 9 to get to our vertex. So that's negative 2, negative 9. Okay, in most cases, once you know the vertex, that's the biggest piece. Now there's some other parts we have to it. Does it open up or open down?
Down.
Which one?
Down.
Why up?
Because it's not negative.
It's a positive, right? In front of the x squared, it's a positive, so it opens up. Okay? If I had a number in front of the x squared that's negative, it would face down. It's going to go up.
So that all, whether it goes up or down depends on what's in front of the x squared.
It's whatever is right there.
Okay, so if it's a negative, it's down.
Yep. Negative, it's going down. It's sad. It's frowning. Positive, it's happy. It's positive. Whatever number is right there. So, I know it's going to open up. I could plug in points there. I could plug in like a negative 1, negative 3 into the equation, and it would tell me where to plot on these. But I also have something called the Y-intercept. For the Y-intercept, I'm going to let x equal 0. Yep, and it turns out to be y equals negative 5. Now the quick way really is to say, well, if x is 0, that's gone, it's just whatever the constant is on the end. So I then go down 5 on the y-axis, and it's right there.
Wait, how do you know that x is 0 again? Which is
Whenever I want the y-intercept, it's going to be on this line, and on this line, x is always 0. So I just drop the x's, and it's y equals -5 is my y-intercept. Anytime you have an equation like that, that's almost faster to find than the vertex. Because you just look, oh, last number, that's the y-intercept. Now, why I like the y-intercept is, first of all, it gives me a point that my graph goes through, but it also gives me a point to the other side. If I went up to here, I could go over 2 to the other side, and it would give me another point, because it's 2 away from the axis of symmetry. It's like when you do a reflection. It's just going to go straight across, 2 units away. So that is at -5, but what's the x value for that point?
4,
Yeah, -4. Which also, we think about it, we went from 0 to -2, we go another -2, we're at -4. Okay, there's our other side. All right, now, because it opens up, do we have a maximum or a minimum?
Minimum.
Yeah, minimum. And the minimum is the vertex, which in this case we said was -2, -9. Now from that, we also can get the range. The range is the y values that work. So whatever we have, min or max, that's going to kind of be the end of the range, and then it's going to go in one direction from there. So -9 is where the range is going to be cut off. Now, do all the y values above it or below it work?
Above it.
Yeah, above, everything up, going up from there. So you're going to say y is greater than or equal to 9 for the range. Whatever the minimum maximum is. If it's a minimum, it's y is greater than those values. If it's a maximum, which our next one will be, we'll look at that, it's going to be less than the values. But it has to do with that 9. Now the other one related to range you also see from time to time is the domain. The domain is the x values that work. We'll just make this easy for right now. In all the parabolas that we're going to look at, the domain is always all real numbers. It's not going to be something cut down. That's not to say it's never that way, but we're just going to give you ones that work nicely. All right, how many solutions would this parabola have? How many times would it hit the x-axis?
2.
18.
How many times was it going to hit the x-axis right here?
2 times.
2 times. So for number of solutions, it would have 2. This is kind of jumping. We'll get to this part a little bit later. But if I want to find the solutions, you can factor the x squared plus 4x minus 5. What does that factor to be? Multiplies to -5, adds to 4. Positive 5, -1. So that means x is equal to those opposites, -5, +1. Which, we come back to this and we actually draw it, it would go through those 2 points. So that is something you could also get from the graph. It's where it hits the x-axis. What's tough about relating it to all of this stuff is most of the time it doesn't hit nice numbers. It hits numbers that are not going to be whole numbers. We're not going to mix this stuff in so much. It would be its own separate problem. We'll get to that. All right, so that's an x squared plus 4x minus 5. If we then looked at the equation, stick with the same form, but now make it y equals -4x squared plus 8x plus 5.
What would you get if you used that other formula we did where it's like b squared or something like that?
-b plus or minus square root. That's going to be quadratic formula. That would have given us these. It would have given you the solutions. And we'll do that part a little bit later. Okay? That, using that for graphing, we're not going to see that too much. All right, so we look at the equation. We got a bunch of information we can pull from it. What's something you see?
Y-intercept. Oh.
Okay, start with that. Y-intercept is what?
5.
Sorry. He's excited. Okay? It's 5. So that means he wants to be on the video.
No, honestly, I don't really care. I just want to submit a deal.
You're just excited it's 5.
Oh, yeah.
Good thing it wasn't 6. All right. Hits at 5. We know that. All right, what else? Something easy from it.
It's going down.
Yeah, opens down.
Because it's a negative 4x.
Yep. And that's because we have a negative 4. But also with the 4 out in front, is it going to make it wider or more narrow?
Narrow.
Yeah, it's going to be narrow. And that's because it stretches it. When there's that 4, it stretches it vertically. It looks like it's skinnier. But that's something also we can look at. So it doesn't help us graph it, but it's things we're thinking of as we start to piece it together. So we know it should go through 5, and we know it should be facing down. Okay, now we got to find the axis of symmetry.
Good talk.
So we go x equals what? On top I'm going to do negative
4 times.
negative
I mean
8
negative.
over 2 times
Negative 4.
Oh man.
step negative b over 2a. So I got negative 8 over negative 8, which is 1. So it's going to go through 1. So actually our y-intercept and our axis of symmetry, or our vertex, are actually pretty close to each other. Okay, so now to find our vertex, we plug in the 1 to our equation. Y equals negative 4 times 1 squared plus 8 times 1 plus 5. Negative 4
9.
plus 8 plus 5. Is that 9?
Yeah.
So our vertex, that space, right here, is at 1, 9. All right? So it actually goes through that. We see that it is narrow.
Could you write the vertex formula again for me, please? I didn't read it all.
Okay, what we do is we go negative b over 2a to find x, and then plug that into the equation that we had.
Okay, so I thought that was axis of symmetry.
The axis of symmetry is it's the x value for it. Because the vertex is on the axis of symmetry, so you figure out where that line is, and then you plug in that number and it gives you the vertex. Okay, so I got 1, 9, I got, this is 0, 5. Give me another point I know for the problem.
The other one's
2,
gonna
5.
be on the other side.
Yeah, other side, we got 2, 5. Opens down. Okay, definitely skinnier, more narrow going down. It's going, is that a maximum or minimum?
Maximum.
Maximum, good. Which means the range, the biggest value is 9. Is y going to be less than or greater than that?
Less than.
Yeah, so it can be less than or equal to 9. So, I give you an equation like that. Different questions you could be asked for. What's the vertex? What's the axis of symmetry? Maybe comparing its width, you know, with the 4 there compared to the first one with just an x squared. What's the range? This one, we're not going to ask you for zero solutions. It'd more just be here, factor it. And we don't need to go into factoring one like this, but graphing it, if I gave you this equation and then gave you 4 graphs, being able to pick which one matches it, that's the kind of stuff you need to have from it. So it's not that you, every time it's, here's the equation, name everything. It's working through finding those different pieces, and any of those we could find from it. Okay, let's go to the other form that we have. We're going to call it vertex form. Now, this one is already kind of almost factored down. You use something called completing the square to get to this. We're not going to have to worry about going between these two forms. It's more if they give you it in this form, you say, okay, we follow the rules for this. What's nice about this one is A is still opens up or down. Whether it's positive or negative, it also determines the width. So the same one as before. The bigger that it is, the skinnier the graph would be. The smaller A is, let's look like 1/2, 1/4, the wider it's going to be. Positive, it opens up. Negative, it opens down. So that stays the same. We have that. What's different is, what I like about this one is we automatically know the vertex. In this form, the vertex is HK. H is there, K is there. You read the equation, you automatically got vertex. I don't have to spend my time with an axis of symmetry. We just pull the values from it. The difference, or the one thing you got to pay attention to, is it's minus h. So you got to change the sign as you take it out. So if we look at y equals 2 times x minus 4 squared plus 3. My vertex, I change the sign on the 4. It becomes a positive 4. The 3 stays the same. So automatically I know the vertex is 4, 3. A lot faster than the other one.
What if it's a like x plus 4?
You would make it negative 4. Just change the sign. So the other one we'll do, I'll write it out now because it fits it. If we did negative x plus 3 squared minus 4, we would then say our vertex is negative 3, negative 4. Change the sign on the x, y stays the same. All right. Which one opens up of those two? Left or right?
Left.
Yep, opens up. The right one opens down because there's the negative out in front. The 2, this one's going to be more narrow. The negative 1 is just going to be like our normal. It's not going to be stretched out at all. Which one's going to have a maximum?
The one on the right.
Because it opens down, have a max, good. Minimum for the one on the left. You get space here. So over 4 up 3. Okay, you said it opens down, opens up. Okay, I'm not going to worry about plotting points for this one.
Shouldn't it be the other way around?
Oops. Okay. Thank you.
You're welcome.
Good, now we don't have to worry about zeros because there are none. Okay, on the left we open up, on the right we open down. What's the range? For the one on the left?
It will be 3. I mean, y is.
Involves 3, then equal to 3. And on the right, less than or equal to negative 3. Or negative 4. Over there. What's tough on this one, and I don't think you're going to be asked it, this is more just under finding the vertex, is the y-intercept. You got to be careful here and not just pick the last value. What you'd have to do for this is your y-intercept, you'd make x 0, and then have to simplify it down. So if I look at the one on the left, if I let x equal 0, it's y equals 2 times 0 minus 4 squared plus 3. We get 2 times negative 4 squared plus 3 Negative 4 squared is 16. Times 2 is 32. It comes out to be 32 plus 3, or 35, which is definitely off of our graph there, but that's how you find the y-intercept. I don't think you'll need to do that too much, but I just want to make sure you're clear it's separate than the first one, where it's nice because standard form you just pick the last number. Really for this one, it's gonna be the less intensive. Find the vertex. Does it open up, open down? All right, let's go to the non-graphing form of looking at functions graphs, if that makes any sense. Okay, get over table. So we're going to have x, and we're going to have f of x. So let's fill in some values here. Now, this reads horizontally. Your points would be like 0, -4, 1, 1, 2, 4, 3, 5. You could draw a graph off to the side, graph it, and then pull the information. But we can also start to see some things here that we may not have to graph it if you understand the pattern. Again, your x values are the one on top, your y values and plotting it are the ones on the bottom. Let's start with, does it have a maximum or minimum? What would be the maximum value? Right there. See that 3, 5? See how the 5 is the biggest y value that it gets? That's the maximum. Okay? So that's the maximum.
What does that say?
It's a poorly written maximum. Okay, well let's kind of take that apart. If that's a maximum, which way does the graph go?
Up. I mean down.
Yeah, up and down. But when we've talked about parabolas, wherever the maximum is, what point is there? Think about it. When you look at the graph and you look at the maximum, what is that point also called?
0. The vertex.
Yeah, that's the vertex. So what's the vertex in this equation?
3, 6.
5. Okay, what we did. Looking at my x values, it went from -4 to 1 to 4 to 5, so it was going up, and then suddenly it starts going back down. It reached a maximum.
Oh, so it's like a loop.
It reached a peak. Yeah, it's a parabola still. It reached its peak, and now it's going to start going back down. I don't know what it does after that. I don't care. I don't need to know what it does after that. I just know it reached a maximum. Then it opens down, so that means the vertex is at that point. So I read it, I know where the vertex is. What would be the axis of symmetry?
3, 6. I mean 5. No, it would be 5.
Is the axis of symmetry the x value or the y value?
The Y.
The y.
Go back to here. We found it first. It first gave us the x value, right?
Oh, yeah.
X. So it's x equals 3. So you find the vertex, axis of symmetry is the x value in there. Okay, let me do another one real quick. See if you can pick up the pattern. So we'll go x and f of x. Let's do So we go from -4 to 2 on the top row, and then the bottom row, 0, -3, -4, -3, 0, 5, 12. Okay. Where's the vertex?
212.
Looking at the values in the bottom, when does it change direction?
-1, -4.
0.
I went from 0. We can even sketch it out. I went from 0 to -3 to -4 to -3 to 0 to 5. See how it kind of turns and changes direction right there? That's where your vertex is. The vertex is where it changes direction. So, your vertex is -2, -4. Which way does the graph face?
Down.
What does it do on either side of the vertex? Is it getting bigger or smaller?
Bigger.
Bigger, so it's going up. Okay, I can plot this if I needed to.
So it's a minimum.
So I went -4, 0, -3, -3, -2, -4. Looks like this. Okay, didn't plot all the points. I didn't plot at 1, 5, and 2, 12. I don't need them though, because I know my vertex is at -2, -4. So you may get a table written like that. If you can read it to find the vertex, do that. Otherwise, you can always sketch the graph of it, plot the points. Just make sure you read it correctly to plot the points. You'll get there. That vertex, though, is where it changes direction. All right, let's go now. Rate of change. Okay? When you see rate of change, I want you to think slope. Now, we know slope, hopefully, as the change in y over the change in x. You may also know it as y2 minus y1 over x2 minus x1. We're not going to necessarily have to use the slope formula. I want to hopefully show you a way to get around it. You can just count, but it's there if we do need it. So, we're going to take the function y equals x squared minus 3x plus 4. And I'm going to write out some values for it. So let's go with 0, 1, 2, 3, and 4. So 0, it hits 4. 1, it hits 2. 2, it hits 2. 3, it hits 4. And 4, it hits 8. So I went through, plugged them in already. Okay, I plugged in x values. I got the y values as a result.
What are you doing?
Just showing you the points on the graph. I'll graph it now and show you. I plugged them into the equation. I took, right here,
I know, I'm kidding.
took those, I picked x values and I plugged them in. I did them ahead of time so we don't have to sit there and plug it.
I don't know how you plug everything.
I plugged 0 into this. 0 plus 0 plus 4 is 4. I plugged in 1. 1 squared
Said that.
minus 3 plus 4 is 2.
Okay.
Okay?
I'm going to do that on the test.
You might if you need to plot points.
Well, are you showing this? This is what
All right, so I have these points. Where would you say the vertex is? We don't need it here, but where would you guess?
It'll be 1.5.
1.5.
Yeah, right between there. And who knows what the y value is for it, but
No, 1.5.
Too bad you already cut it down.
okay, we can plug it in. I'm not worried about the vertex. I just want you to at least look at the graph here. Okay? If I'm looking at certain parts of it, it's not the same slope all the time. Yes? Agree with that?
Yeah.
If I looked at between 2 points, the slope is between 2 points. So if I went the slope right here, between those 2 points, it's going down. And then the slope right here, it's going up. So as we move about the graph, the slope changes. That's different than what we've seen in the past. If I asked you to just graph a line, it would have the same slope always. So we can't look at this whole equation and say, here's the slope, because it's constantly changing. What you need to be able to do is find the slope between 2 points and see how it compares to other intervals. So we're going to take those numbers, when I pick these, and look at the differences in the slope. So if we look at call it the rate of change, let's look between 0 and 1. Okay? The long way to do this is its slope between 0 and 1. Our y values are 2 minus 4. Our x values are 1 minus 0. And I pulled those from right here. So I did 2 minus 4, y2 minus y1, 1 minus 0. That gives me negative 2 over 1, or negative 2. Do you agree that between 0 and 1 it has a negative 2 slope? At least negative. Do you agree with that? 0, 1. It's going down. Okay. Now, a quick way we could do this is all of our x values are 1 apart. So really, it's just how far did it go down? It went down 2. So from 4 to 2, it's negative 2. What if we said between 1 and 2?
0.
So we could say our y values are 2 minus 2, x values are 2 minus 1, comes out to be 0. Is the slope 0 between those 2 points?
Yeah.
Didn't change, didn't go up or down at all. Between 2 and 3?
2.
I heard 2. You got some 2? It's going up, right? Between 2 and 3, our y value went up 2, so our slope is 2. What about between 3 and 4?
4.
4.
Now it's 4, right? Went to 4 to 8. So we'd say it's 2. 3 and 4. It's 4. And we can compare. So really, once you get those, maybe the question is, when is the rate of change the biggest? Or which one's larger, which one's the same? You could compare through that. Let's make a prediction, though. If I then went and plugged in 5 here and got some number, do you think the slope's getting bigger or smaller as we keep moving to the right?
Bigger.
So like between 4 and 5, do you think it's going to be more than 4?
Yeah.
Yeah, because knowing a parabola, it gets steeper as it's going up. So we plug in 5, and we look at the slope between 4 and 5, it's going to keep getting bigger. And even if we went to the left side, over on the negatives, they would keep getting kind of bit larger negative numbers going there. They hit 0, and then they start going back up. So you'll see that where you have to compare the slope between 2 points. Figure out the difference. You can just see which one's larger, which one's smaller. Slope works the same way. You know, the larger the slope is, the steeper the line is going up. All right, next, let's shift to solving. Okay, our first step for solving. All of it really is factoring. Okay, that's what it comes down to. It's stuff we've done last chapter. If factoring doesn't work, we'll come in and use quadratic formula, which we talked about last week. Let's start with one basic, though. If I had x squared minus 100 equals 0. Two ways we could approach it. One way is to go, well, that's x squared equals 100. And then I can take the square root of both sides.
X minus 10, x plus 10.
And it comes out to be x equals plus or minus 10, or positive 10 and negative 10. Because that means if I plugged in positive 10 or negative 10 into my original equation, it works. Because 10 squared minus 100 is 0, and negative 10 squared is 100, minus 100 is 0. Okay, another way we could have done that. We go back to our last chapter, that's the difference of two squares. So that factored is x minus 10, x plus 10, equals 0. In this chapter, we had something called the zero product property, which means if you multiply two things and they equal 0, you just set each of them equal to 0. So x minus 10 equals 0 gives us x equals 10. And x plus 10 equals 0 gives us x equals negative 10. We get the same result. So you'll see basic ones like that. That really, yeah, we use difference of two squares, but it's more the basic factoring that we have. Okay, put that one aside. Let's look now at x squared plus 3x plus 2 equals 0. Okay, we've jumped back a few weeks. We're back in our last chapter, and I asked you to factor that. You're looking at ways you can multiply to 2 to add to 3.
2 and 1.
Perfect. So we go x plus 2, x plus 1 equals 0. Yeah, you set each of them equal to 0 by themselves, and you get x equals negative 2, and x equals negative 1. It's solved. Those are the solutions. So when it asks you to solve, find the solutions, that's all you do. Okay, what if we went 2x squared plus 7x minus 4 equals 0? I'm looking ways to multiply to what?
8 and 1. Negative 1 and positive 8.
Okay, so negative 8, right? Add 7. You said what? Negative 1, positive 8?
Yeah. No. Oh, wait, yeah, you're right.
Okay, multiply to negative 8, add to 7, negative 1, positive 8 would work. The way we did this is we don't make it x minus 1, x minus 8. We then split the middle term. Question?
Where'd you get the negative 8 from?
I did negative 4 times 2.
Oh,
When we have a number out in front, we multiply those two.
but you don't multiply the middle one?
No, that's the one we add to. We add to the middle one, we multiply to the outside. All right, so where do we factor? We split them, negative x and 8x. I factor out of the first two, I get 2x minus 1. What can I factor out of the next two? Remember, I wanted to get it to match 2x
4.
minus 1, so I have to
4.
factor out. 4. Okay, so 2x minus 1 matches, and then the leftovers are x plus 4. So we did this to get to the factored form. Now we set each from equal to 0. X plus 4 equals 0 gives us x equals negative 4.
And then positive 1/2.
2x minus 1 equals 0. Let's add 1. Divide by 2, we get 1/2. We have 1/2 and negative 4. So this point, or this point, is what we've already done. We just then set each of those parts equal to 0, solve it. What this means to the graph, if I went back to the first one we looked at, it tells us that the graph has solutions at -2, -1. And when we say that, it just means that's where it hits the x-axis. If I went off just that for that equation, that's where it hits. I know it's positive, so it would open up. I could kind of sketch and have an idea parabola looks like that. Now, I wouldn't know the exact points, but it would be enough to just relate back to the graph if needed. And then obviously the one on the right would be 1/2 -4. So that would be out here and here. That one's a positive, so maybe it looks like that. We don't know the values for the vertex. We could find that. That's a separate process, but at least it does relate to the graph we have. So, what do we do when we can't factor it? Or, an option is if you don't like this factoring process, what's your alternative? That's where the quadratic formula comes in.
That means it's not factoring.
It works for every one of them. You could use it every single time. It's just like the one we talked about right here, the x squared plus 3x plus 2. If you can factor that quickly, it is faster than the quadratic formula. But this can be your go-to. This works every single time and tells you what your solutions are. It also tells you if they even exist. If we get a square root of a negative, everything's off, no solution, we don't have to finish it. It's your last option if the factoring didn't work.
So, like, say you want to screw up in the factory, you just,
If you're not good in the factoring, I would use this every time.
okay.
It's the process that you plug in the numbers, gives you an answer. It may take a little bit longer, but
So
it's going to
I'm
work.
stick with this.
Yes. So it is x equals negative b over, or negative b plus or minus, square root of b squared minus 4ac over 2a. Every time, that's the formula. What changes is your a, b, and c value. And you get your a, b, and c value from your equation, which is ax squared plus bx plus c. Take a, b, and c, you plug it in. You simplify, you get an answer. Sometimes it'll work out nice, sometimes it won't. Sometimes it'll have no solution, but it gets you the answer. Now, if you don't memorize the quadratic formula correctly, it really isn't going to help you. So you need to make sure you have to memorize it.
And you said you only do that if you can't factor.
Yeah, factoring doesn't work. If you don't like factoring either, it's an option. So let's go x squared minus 19x plus 70 equals 0. Now, in this case, we could probably factor it 14 and 5, multiply to 70. When they're negative, they add to negative 19. But for the sake of showing it, let's use quadratic formula. What's your a value? Yeah, it's a 1, so a equals 1. B is negative 19, C is 70. Like I told you, it's going to work every time. It's your go-to. So we go a negative of negative 19 plus or minus square root of negative 19 squared minus 4 times 1 times 70. All of that is over 2, because a is 1. And as we talked about before, really the hard part about quadratic formula is simplifying the square root, especially if it's not a perfect square. Let's see what we get here. I got 19 plus or minus, or 19 squared we get 361. That's going to be minus what? 4 times 70? 280. Okay? Over 2. What's 361 minus 280? $81. Is that a good thing or a bad thing?
Good, good.
It's a very good thing. We got a perfect square. I mean, this is going to work out nicely. if it wasn't, if it was square root of 82, it's not that it's wrong, it just would be a radical. We'd have to leave it as the radical form. All right, so I'm going to get x equals 19 plus or minus 9 over 2. We're not going to leave it in that form. We need to solve it in the two ways. We're going to solve it in one way, where it's x equals 19 plus 9 over 2. And we're going to solve it the other way when it's x equals 19 minus 9 over 2. So for the top one, I get 28 over 2, which is 14. The bottom one, I get 10 over 2, which is 5. So our answers, 14 and 5. The other option there, if you didn't see it, or if you did see it, is you make it x minus 5, x minus 14 by factory, then set them both equal to 0. You get x plus 5, or x equals 5 and x equals 14. It gets you the same answer. This is just another process. Okay, let's do another one. Let's go 15x squared plus 20 equals 40x. Before I use quadratic formula, what do I do?
Subtract 48.
Do what?
Subtract 48.
Yeah, got to move it over. Got to have everything on the same side. 15x squared minus 40x plus 20 equals 0. Okay? What else could I do? Yeah, let's factor something out. We want to work smarter here. We don't want those huge numbers to plug into quadratic formula. What is a common factor in all of them?
5.
Yeah, so 5 comes out. 3x squared minus 8x plus 4 equals 0. Now, when I plug into quadratic formula, it's going to be a lot nicer to use 3, 8, and 4 instead of 15, 40, and 20. Now, when I factor the 5 out, it divides over, so it's actually gone, and we're left with 3x squared minus 8x plus 4 equals 0. A is 3, B is negative 8, C is 4.
You just leave that 5 out.
Yeah, because it factors out and the other side's equal to 0, we basically would divide it over, it's going to be gone. It's not that 5 is a solution, it's just a factor we don't need. So we're going to go x equals, it's going to be negative b, so that's just going to be an 8, because it's negative 8, plus or minus square root of negative 8 squared minus 4 times 3 times 4. All of that's over what?
6.
Yeah, 2 times 3, 6. All right, let's take care of the square root first. Leave the 8 and the 6 alone. Do not reduce them yet. Okay, so I got a 64 minus what?
Minus 8.
Minus 48.
Oh.
All right, we're good so far. What does 16 minus 48 become?
16.
64 minus 48. Yeah, what's 16? Good thing or bad thing?
Good thing.
It's a good thing, right? Becomes 8 plus or minus 4 over 6. So one of them, we're going to make 8 plus 4 over 6. The other one, 8 minus 4 over 6. What's the top one going to be when it's addition?
It's going to be 12 over 6.
So 2. What's the other one?
2 over 3.
Yep. 4 over 6 becomes 2 over 3. Your two solutions are 2 and 2/3. Okay, last thing I want to show you. Hopefully not to scare you. Let's just kind of look at a word problem here. And it's important that we understand we are going to have to relate these back to word problems from time to time. And area is usually the way that we'll do it. So you have a box, prism, rectangular prism, that is 4 feet tall. And the length on the bottom is twice the width. Okay? You also know that the area of the whole thing is 288, not the area, it'd be the volume, sorry. Volume. 288 feet cubed. So, if the length, let's go with the width. If the width is x, what's the length?
2x.
Yeah, it's 2x. So off of the length equals 2 times the width, we have those two dimensions. We now know it's 4x and 2x. So if I wanted to find the volume of the rectangular prism, I would do 4 times 2x times x. What does that multiply to become?
8x squared.
Good. Equals the volume. But I also know the volume is equal to what?
288.
288. Now our goal here is to find what those dimensions are. How am I going to solve that?
Finding your width.
What do I do next? Do I take the square root? Divide by 8? Okay. X squared equals then 36. Yes. So what does it make the solutions if I take the square root?
6.
And? Yeah. So in that equation, 6 and negative 6 are the solutions, because I had x squared equals 36 plus or minus 6. Now, do those both work to the scenario we have?
No.
No. Why? Why does one of them not work?
Because it's not
Can't
x
have a
equal.
negative sign.
Yeah.
Oh, yeah.
And again, I got to stress this. Those are the two answers to the equation that we solve, but for the problem itself, the negative does not work. So you can only use the 6, and you would say that the width is 6 feet. What's that make the length?
12.
Yeah, 12 feet. Okay? You only can use the positive because it's talking about measurement or area. Negative 6 does work, but we're not going to have measures in a negative. Okay, so word problems, they'll come up. Really on the word problems, it's can you set it up and solve, and then it's like all the other ones, and then you want to make sure you pick the positive solutions if you have them, just because those are the ones that are going to fit most of the time.